$50 billion.
Yeah, which is, I mean, it's a staggering number to even think about.
It really is. That is the number on one side of the scale this week, and on the other side, a literal piece of glass.
Right. A piece of glass small enough to just, hold in the palm of your hand.
But capable of archiving data for 10,000 years.
Exactly.
Welcome to the Deep Dive. I'm your host, and we are looking at a week of massive contradictions here. We're talking about the largest AI infrastructure investment in the history of the Global South, which is aiming to basically rewire the economy of entire continents.
And at the exact same time, we're talking about manipulating matter at the molecular level.
Yeah.
With lasers.
Right, lasers that pulse faster than a molecule can even vibrate, which is just wild.
It really sounds like science fiction. But this is the reality of the Microsoft AI ecosystem for the week of February 15th through the 21st, 2026.
Yeah.
We aren't just looking at new chatbots here. We're looking at a fundamental shift in how human knowledge is stored, how software is built, and frankly, who gets to participate in the future economy.
So for everyone listening, that's our mission for this deep dives. We've got primary sources, research papers, Microsoft tech blogs, and policy announcements from this week. And we want to get straight into the how of all this, because the headlines are flashy, but the mechanics, the actual underlying tech is where the real story is.
Let's start with the research, specifically the paper that dropped on February 18th regarding Project Silica.
Yes, the glass storage project.
Microsoft Research published the details in the journal Nature, and it addresses a problem we honestly don't talk about enough, which is the durability crisis.
The durability crisis.
Yeah.
Because, as users, we tend to think of the cloud as eternal.
Yeah.
Like I upload a photo to Azure or whatever, and it stays there forever. But physically?
Physically, that's completely false.
Right.
Most cloud storage is actually just magnetic tape or spinning hard drives, and they degrade, tape binds, the drives seize up. So you have to constantly migrate that data to new media every, I'd say 5 to 7 years.
Which sounds exhausting.
It's an incredibly active, expensive process, and it consumes a massive amount of energy just to keep the data from essentially rotting.
So enter the glass. What exactly did Microsoft Research achieve this week? Because, I feel like I've heard about glass storage as a concept for years now.
You have, yeah.
Oh.
But the breakthrough published in Nature is specifically about the writing mechanism. They are using femtosecond lasers to encode data into borosilicate glass.
Okay, femtosecond. That means extremely fast, right?
No, beyond fast. It is 1/4,000,000th of a second.
Wow.
To give you a sense of scale, a femtosecond is to a second what a second is to about 31 million years.
Okay, that is honestly impossible for my brain to visualize. But why does the speed matter so much? Like, why not just use a normal laser?
It all comes down to heat. If you use a longer laser pulse, you heat up the glass, it expands, and then it cracks. You just end up damaging the material.
Oh.
But a femtosecond pulse is so incredibly fast that it modifies the structure of the glass, creating what they call a phase voxel before any heat transfer can even occur. It's a completely cold-write process.
The phase voxel. That sounds straight out of Star Trek technobabble.
I know, right? But it's actually quite elegant. So a normal pixel on your screen is 2D. A voxel is just a 3D pixel. They're etching these tiny microscopic gratings inside the glass that change how light passes through it, specifically the polarization of the light.
Got it. So it's not on the surface, it's inside.
Right. And when you want to read the data back, you just shine a light through it, and a microscope reads those polarization changes.
And because it's a physical modification inside the glass itself.
It is virtually indestructible. You can boil it, bake it, scrub it with steel wool, or hit it with an electromagnetic pulse. The data remains completely intact. They estimate a 10,000-year lifespan.
10,000 years. That completely changes the economics of storage, doesn't it?
Entirely. Think about cold storage. This is the data you need to keep but you rarely look at. Legal archives, medical records, or, and this is the big one for our focus, the massive data sets used to train AI models.
Right, the training data.
Exactly. Right now, keeping that data costs electricity because you have to cool the server farms. With glass, once you write it, the energy cost drops to literally zero. It just sits on a shelf. It's passive.
That is such a crucial distinction, and we're definitely going to come back to that when we talk about energy later. But there's a catch here, right? If we're building a library that lasts 10,000 years, we need to know that what we are storing is actually authentic.
Yes.
Because on February 19th, Microsoft Research also dropped a pretty heavy report on media authenticity.
This is the exact other side of the coin. Durability is great, but provenance, knowing where the data came from, is essential. especially as generative AI models like Sora become capable of creating video that is completely indistinguishable from reality.
Right. The question isn't just can we store it forever, it's should we trust it?
And the report admits we are really struggling with that. They evaluated current standards like C2PA.
It is basically a digital label that travels with a file.
Exactly, it's metadata. But the study found that those labels are incredibly fragile. You strip the metadata, you completely lose the provenance. However, Microsoft did release a new tool alongside the study called TempoMark.
Which is a watermarking technique for video.
Yes, but with a specific focus on resilience. Usually, if you compress a video to upload it to, say, YouTube or TikTok, the compression algorithm completely destroys the hidden watermark.
Oh, because it throws away the extra data to make the file smaller.
Precisely. But TempoMark embeds the signal in the frequency domain of the video.
Okay, the frequency domain. Explain that for us.
Think of it like this. Instead of pinking a signature in the corner of a canvas, which can be cropped out, you are weaving the signature into the canvas threads themselves.
Oh, I see.
So even if you cut the canvas or take a blurry, low-res photo of it, that underlying weave pattern remains. Their tests showed a 99.8% recovery accuracy even after heavy compression and cropping.
99.8%.
Yeah.
That feels like a genuinely necessary piece of infrastructure if we're going to have any shared sense of reality in the future.
Definitely.
But sticking with the research lab for just a moment longer, there was one more release that seemed to go in the exact opposite direction of these massive 10,000-year projects, and that's the Phi-4.5-Mini.
Ah, yes. While product Silica is about forever, Phi-4.5-Mini is about right now, directly on your phone. Microsoft released this around February 18th, and it's a 3.8 billion parameter model.
Now, in an era where we're talking about trillion parameter models all the time, 3.8 billion sounds almost quaint.
Yeah.
Why is Microsoft pushing this small model so hard?
Because of the edge. We simply can't run everything in the cloud. The latency is too high, and the privacy risks are getting too great for certain applications. This model is highly optimized for mobile chips and IoT edge devices. And it's actually 2.1 times faster than the previous Phi-4 version on ARM processors.
So this is really about decoupling intelligence from internet connectivity.
Precisely. If your smart glasses or your car needs to make a split-second decision, it cannot wait 500 milliseconds to ping a data center in Virginia. It needs to think locally. Phi-4.5-Mini is essentially the brain designed to fit tightly into those small spaces.
Which is actually a perfect segue to our next segment on products and developers. Because if Phi is the brain, this week we got a new way to organize the whole body. The Microsoft Agent Framework hit a major milestone.
I would argue this might be the most consequential update for developers this entire week. On February 19th, the Agent Framework officially reached release candidate status for .NET and Python.
Okay, so I feel like the word agent is getting thrown around right now, kind of like cloud was 10 years ago.
Oh, absolutely.
Everyone uses it, but nobody really defines it. How is building an agent in this framework different from just building a chatbot using an API?
That is the exact right question. A chatbot is fundamentally a conversational loop. You say X, it replies Y. It's totally reactive. An agent, on the other hand, is goal-oriented.
Okay.
You give it a mission, like plan my business travel for next week or refactor this entire module of code, and the agent itself determines the steps required to get there.
So it actually has agency. It decides the how.
Correct. But the framework part of the agent framework is what matters here. We are moving away from single agents to full-blown orchestration.
Orchestration.
Yeah, imagine you're building a software startup. You don't hire one person to do design, back-end, front-end, and legal. You hire specialists. The agent framework allows developers to easily spin up specialized agents like a coder, a reviewer, a manager, and coordinate them.
So the manager agent gets the prompt, breaks down the task, and then assigns it to the coder agent.
Exactly. And this release candidate status means the plumbing for that complex interaction is now considered stable enough for real-world production use. It moves from being a cool experiment to a reliable industrial tool.
And part of that plumbing is something called MCP, right? The Model Context Protocol. I saw that heavily mentioned in the semantic kernel blogs this week.
MCP is huge. Think of it like the USB standard, but for AI. Before MCP, if you wanted your agent to read your Google Calendar, you had to write custom API code. If you wanted it to read a SQL database, more custom code.
Right, constantly reinventing the wheel.
Exactly. MCP provides a standardized way for agents to just plug in to diverse data sources.
So it prevents the agent from basically just being a brain in a jar.
It gives the brain hands and eyes. And more importantly, it does it securely, so you aren't hard-coding sensitive credentials everywhere.
Now, if we have all these specialized agents running around doing complex work, they clearly need to be able to process a massive amount of information. And that's where the Model Garden update comes in. Claude Sonnet 4.6 launched on Azure.
Yes, it became generally available on February 20th. And the absolute headline feature here is the context window, 1 million tokens.
Again, help us visualize that. What does a 1 million token context window actually look like?
It's roughly 700,000 words. You could feed the model the entire Harry Potter series, plus The Lord of the Rings, and you'd still have room left over for a few dense textbooks.
But wait, why do we even need that if we have these new agents? Can't the agents just search and look things up in smaller chunks?
There's a fundamental trade-off. Agents are great for doing, iterating, searching, taking actions. But super large context windows are for synthesizing.
Synthesizing, okay.
Say you have a 30-year-old legacy codebase, and you want to ask the AI, how does the billing logic over here relate to the user profile table over there? An agent might really struggle to find that connection by just searching file by file. But a model with a 1 million token window can hold the entire code base in its working memory all at once, and it sees the connections instantly.
So the super large context is for deep, holistic understanding, and the agents are for execution and action.
That's a very fair way to split it. And Microsoft is clearly making sure these tools aren't just reserved for the Fortune 500. On the 19th, they also launched something called Budget Bytes.
Yeah, I saw that. Budget Bytes.
Which are basically templates to build AI apps for under $25 using Azure SQL, alongside Copilot for Finance, which just launched in preview in the US and EU to automate things like variance analysis.
Which is really democratizing AI development at the micro level. It's practical. But I want to pivot and zoom out to the macro level.
Okay.
Because while a $25 app template is great for small businesses, the real money is moving elsewhere. Let's talk about that $50 billion figure from the cold open.
Right. This was the massive news from the India AI Impact Summit on February 17th. Microsoft announced they are on pace to invest $50 billion by 2030 to close the AI divide in the global south.
$50 billion is just a staggering amount of capital. What is driving that kind of urgency from Microsoft?
The gap between regions is widening fast. Current data shows that AI adoption in the global north is basically double that of the global south.
Oh, wow.
Yeah. And if that trend continues, we are looking at a repeat of the Industrial Revolution, where a few specific regions hyper-accelerate and the rest of the world just becomes a resource colony. Microsoft wants to prevent that, or at the very least, they want to ensure they have viable markets and customers in those regions in the future.
At the summit, Brad Smith outlined a 5-part plan. But I really want to focus on the two hardest parts of that plan, the infrastructure and the skilling.
Infrastructure is definitely the main bottleneck. I mean, you can have all the open source models you want, but if you don't have the data centers and the fiber optics to serve them locally, they practically don't exist. Microsoft invested $8 billion in this infrastructure last year alone.
But then you have the skilling component. They set a goal to train 20 million people by 2028.
And that's the field of dreams problem. If you build the massive data centers, who's actually going to use them? They need local developers building local solutions.
Like the food security projects they mentioned in Kenya.
Exactly. And that naturally connects to the multilingual pillar of their plan. Projects like Lingual Africa and Project Deco.
Right, because if the AI only really understands English and writes in Python, it completely leaves out a massive chunk of the global population.
Exactly. They're trying to fundamentally create a market, not just serve an existing one. But there is a very real physical cost to all of this incredible growth. We talked earlier about glass storage being completely passive, but the compute needed to run these new agent frameworks and train these models is incredibly power hungry.
Which brings us perfectly to the energy update. On February 18th, Microsoft confirmed they've officially contracted 40 gigawatts of renewable energy.
Just for context on that number, 40 gigawatts is enough energy to power roughly 10 million average homes. It's massive. And it means they have successfully met their goal to match 100% of their electricity use with renewables by 2025.
Okay, so I'm seeing the connection now between the segments. They absolutely have to move cold data to passive things like Project Silica glass.
Yeah.
Because they need every single spare electron they can get to power the active GPUs for all of these agents.
That is the whole ecosystem view right there. Energy is a finite resource. If you waste it spinning hard drives full of 10-year-old unused data, you can't use it to run the new Phi-4.5 Edge model. It is all a massive balancing act.
So we have the power, we have the glass storage, we have the $50 billion,
Yeah.
but we also have the brakes.
Yes, we do.
And this week, Microsoft hit the brakes hard on a major feature called recall. Let's get into the safety and governance news.
They really did. On February 16th, they announced that the recall feature is being disabled by default on all new Copilot Plus PCs, pending a thorough security review.
For our listeners who might have missed the initial controversy, remind us what recall actually does.
It essentially takes screenshots of your active computer screen every few seconds, uses AI to analyze exactly what is in those images, and stores it in a locally searchable timeline.
Right.
So you could literally ask your PC, hey, where was that blue dress I looked at on some website last Tuesday? And it instantly finds it for you.
And security researchers absolutely hated this.
With a burning passion, yes. The initial implementation stored all these incredibly sensitive snapshots in a database that, while technically local to your machine, wasn't sufficiently encrypted against someone who already had user-level access.
Oh, wow.
It was basically a gold mine for stealer logs, which is malware specifically designed to grab your personal data.
So making the decision to disable it by default, pending a review that isn't just a minor tweak to the settings.
No, it's a major concession. It's a public admission that the old tech industry ethos of move fast and break things simply does not work when you are passively recording a user's entire digital life.
Yeah, the stakes are just too high.
It's not just about product maturity, it's about sheer liability. They cannot afford for their flagship AI PC to be labeled a corporate spy device.
Well, speaking of liability, there was a highly significant bug in Microsoft Office confirmed on the 18th.
Ah, yes. Bug ID CW12263224. This was a really nasty one. It essentially allowed Copilot to summarize highly confidential emails, even when strict data loss prevention or DLP policies were actively in place.
So wait, if I tag an email at work as internal only or highly secret, the AI just ignores the tag entirely and summarizes it anyway for someone else.
Even worse, it implies that the traditional security controls we rely on, the deterministic rules that explicitly say do not read this, were completely overridden by the probabilistic guessing nature of the AI model.
That is literally the nightmare scenario for any enterprise IT department.
It absolutely is. It reminds us that large language models are not rule followers by nature, they're pattern matchers. If we want them to strictly follow enterprise security policies, we need incredibly rigid external guardrails. And the scary part is, this bug persisted for weeks before the fix, which is simply too long in a corporate environment.
Which I think likely explains the sudden rush to deeply integrate governance tools this week. On February 17th, they launched a new automated onboarding integration where data from AI Foundry agents flows directly and immediately into Microsoft Purview.
This is one of those boring updates that actually makes all the fun stuff possible. Purview is Microsoft's main compliance and governance dashboard. By automatically piping all the agent activity into Purview, they're trying to create an unbreakable paper trail.
So if one of those automated agents goes rogue or just makes a dumb mistake, you can actually audit it.
Exactly. If you're going to deploy those complex teams of agents we discussed earlier, you absolutely need to know exactly what they are doing and what data they touched. You need an audit log for your digital employees just as much as your human ones.
And to wrap up the security front, there was a strategic alliance announced. CrowdStrike's Falcon platform is now officially on the Azure Marketplace as of the 18th.
This is a commercial play, definitely, but a highly significant one. It allows enterprise companies to use their MACC, which stands for Microsoft Azure Consumption Commitment, to buy CrowdStrike directly.
So basically, you can use your pre-committed, already budgeted cloud spend to buy top-tier third-party security.
Right. It completely removes the procurement friction. And right now, following these bugs and the recall pause, Microsoft needs to remove as much friction as possible to get naturally skeptical enterprises to fully trust this new AI stack.
So let's pull all these threads together for you, the listener. We've got Project Silica promising to store our history forever in glass. We have a $50 billion push to ensure the Global South actually participates in writing that history. We have the agent framework completely changing how we build and orchestrate software. And we have massive, very real governance challenges with things like the recall pause and the Office DLP bug.
It is a week that perfectly highlights the industry's transition from the wow phase to the how
Oh, I
phase.
like that. Expand on that a bit.
Well, the wow phase was, ChatGPT writing a poem for the first time or generating a funny image. Everyone was amazed. But the how phase is where we are now. How do we power this tech without melting the global energy grid? How do we secure it so it doesn't leak corporate secrets? How do we structure the software so it's actually reliable? And crucially, how do we distribute it equitably across the world?
It really feels like the AI industry is finally growing up. We're moving away from parlor magic tricks to actual civil engineering.
That is a perfect analogy. We're laying the concrete foundations right now.
But I want to go back to that piece of glass one last time to leave you all with a final thought. We are talking about successfully archiving human knowledge for 10,000 years. We are building the very first truly permanent digital libraries of human history.
A library that survives floods, fires, EMPs, and time itself.
Right. But then we look at that $50 billion investment in the Global South. Because if that AI divide isn't closed, if the infrastructure and the skilling aren't actually built in those regions, then the only history making it onto that 10,000-year glass will come exclusively from the global north.
That is the ultimate risk here. History is traditionally written by the victors. But in the digital age, history is preserved by those with the highest bandwidth and the most advanced lasers.
Exactly. If we want a true representative library of humanity to survive the next millennia, we need to make sure everyone actually has a library card.
And a reliable connection to the grid to use it.
Indeed. Well, that is it for this deep dive into the Microsoft AI universe. We are definitely going to be tracking how these autonomous agents evolve and whether that glass really holds up to the hype. Thank you all for listening.
Until next time.